All right, so for 7.3, we're going to talk about volume again with the shell method. The shell method is comparable to the dishwasher method. We just look at it a little bit differently. So, with the dishwasher method, if we had something like y equals x, and we wanted to know the area under this curve, all right, if we were rotating it around the x-axis, we would choose our slices to be perpendicular to the axis of revolution. Okay. However, with the shell method, instead of going with perpendicular, so if I was going to rotate this around the x-axis again and using the same function, with the shell method, I would go parallel to that axis of revolution. Okay. And so if we're rotating around the horizontal axis, the x-axis, then the volume is equal to 2 pi times the integral CD, or from C to D, of Py Hy. Okay. Py represents the difference between our rectangle and the axis. And then Hy represents the height of our rectangle. Yeah. So Py is the distance, Hy is the height of the rectangle. All right. If we are rotating around the vertical axis, then our integral is written in, let me add this note over here. X-axis, we write it in terms of y. Y-axis, we write it in terms of x. So it's 2 pi times the integral of a to b of p of x times h of x dx. Okay? So those are the two fundamental differences between the shell method and the dishwasher method. All right. The shell method to me is a little more diverse in its uses than the shell method, but it is another way. And you may just look at it at the functions and be able to dictate which route would be easier to find the volume. Okay, so let's look at an example here, and let's look at y equals x. All right, and so the graph of that looks something like this, and we're going to look from 0 over to 2. All right, so I want to figure out what all this area is, and I want to rotate this around the y-axis. Yeah. Then my P of x, so I'm rotating around the y-axis, so I want to use P of x. So my rectangles are going to look like this. They're parallel. All right. X, or P of x, again, is the difference between the center of the rectangle and the axis of revolution. So here it just has a distance of x. Right? If x is 0, it's 0 away. If x is 1, it's 1 away. If x is 2, it's 2 away, and so on. Right? However, since y equals x, the height of our rectangle, h of x, is also represented by x. Okay? So h of x is also represented by x. Because if x is 2, the rectangle has a height of 2 because y equals x. All right? So then that means that the volume of this is equal to 2 pi from 0 to 2, the integral of x times x dx. All right? X times x, of course, is x squared. So I have 2 pi times x cubed over 3 from 2 to 0. So I have 2 pi times 2 cubed over 3, which is 16 pi over 3. So this would have a volume of 16 pi over 3. If you were to use the dishwasher method, you would find the same way, or you would find the same value, just a different method of doing it, okay? All right, and so the second example that I want to talk about for the shell method is if we are given something like x plus y squared equals 49. All right, and so just to give you an idea what that graph looks like, you can use Desmos to help you out on the graphing. It's kind of a oblong circle thing here, so it kind of looks like this, and it crosses at 7 and 49. Right? And so our goal is to wrap this thing around the x-axis, which means that we need everything to be in terms of y. All right? So my rectangles look like this. So they're going to be parallel to the x-axis. All right? Well, the difference between the rectangle and the axis is just y, right? Okay, so it's just y. And then the height of the rectangle is from the, or whatever the height of the rectangle is here, all right, is really just equal to whatever our x coordinate is. So we need to solve this for x. So the height of y will be 49 minus y squared, because our height is dictated by whatever our x value is. So if our x is 49, then our height's 49, and we dictate that with this 49 minus y squared, because that's the line or the curve that's generated. All right, so knowing h of y and p of y, now I just plug into my volume. All right, so remember, I'm looking from C to D now, so I go from 0 up to 7 of y times 49 minus y squared dy, which is 2 pi times, just do a little algebra cleanup, I've got 49y minus 49y squared dy. Do the integration part, and I get 2 pi 49y squared over 2 minus, oh, excuse me, I distributed the 49. I was distributing the y. My apologies there. So it's a y cubed, y times y cubed, yes. So then I have y to the 4th over 4 from 7 to 0. So I'm left with 2 pi times 49, 7 squared over 2, 7 to the 4th over 4. Yeah. And I believe that comes out to being, oh, no, excuse me, I've got the wrong answer here because of my notes being wrong. So let me type it in the calculator real quick. So I've got 49 times 7 squared divided by 2 plus 7 to the 4th divided by 4, and then that whole quantity times 2 comes out to being 7,203 over 2 pi. Sorry about that. I should have checked my notes before. All right. So the final answer for this one is 7,203 over 2 pi. All right. And so that is volume by shells. Okay. So that actually ends our volume section for integration as an application here. So again, the dishwasher method to me is a little more. I like the dishwasher method personally better. One thing that I would do as a Calc 2 student is if I was rotating around the depending on which axis I was rotating around, I would just always choose the one that the function was laid out the best, if that makes sense. All right, and so I just chose the path of least resistance when solving these. All right, so if you have any questions, please feel free to email me. And as always, have a great rest of your day.